Okay, welcome everybody. Anna, Dawn, can you hear me clearly?
Yes, we can hear you well.
That's great. Okay, so my name is Simon Davis, and I'm going to be presenting this Certara University Express webinar on integrating R with Phoenix workflows. And really what we're trying to show here is some of the available code that is there on the CRAN and other resources, perhaps internal. You don't need to be an R programmer to make use of this. We're just showing you how, with an existing piece of R code, you can relaunch that and reuse it easily in a Phoenix workflow with very little knowledge of R itself needed. So it's going to be a 30-minute webinar, including a Q&A session. Obviously, you're all muted, so please use the question panels, and I'll try and answer as many questions at the end as possible. What we're going to be looking at, as I said, is Phoenix, and we're going to be using this R shell here, which you'll find with Phoenix 8.3 under external software. In prior versions, it's got a slightly different menu, but it's been in Phoenix from the beginning. And you can see there's other tools available there as well. So one thing is, if you want to use R within Phoenix, you'll need to go to the Phoenix preferences and let Phoenix know where your R executable is. So that's mandatory, that first option there. And you'll also want to probably set a default output location, so you don't need to type it in for each of your scripts. And optionally, you might want to use the development environment. So when we talk about development environment, we mean accessing our GUI, our Studio, something like that, where you can actually launch R in an interactive way to sort of debug your code. And then once you've run an analysis with R, you'll see that the data comes back into the results just like any other Phoenix object. So you can see it had a setup panel, and we'll be seeing this in the demo properly later. It's got a results panel, and I've brought back from R some images, in this case some plots. We've got the R workspace, which is under other. I've got a worksheet that's come back from R, and I can use that in further downstream objects if I need it. And of course, I have the log file from R. So you might want to check that everything's run as you expected. And lastly, the settings, that's another Phoenix object automatically generated, which confirms the mappings which were used. And I'll go into the lower panel in more detail, but you can see that results panel, output folder, out R is there again. Okay, so there's a few ways to use R from Phoenix, and really the differences are on how you provide data to R. So most commonly, and the one I find the most sort of transparent, is when I'm using a data set already within Phoenix. I can create a mapping panel by putting at the beginning of my R script an attach statement, and then Phoenix will pass that piece of code and produce a mapping panel with the expected column names for each attach statement you've put in. So here I'm attaching a data frame, and it's looking for the columns ID, amount, time, DV, MDV, and event ID. But in my source data set, they don't need to be called that. They can be called whatever I want, and I can just map, so I can map subject to ID. So that I find the most transparent, and for a Phoenix user, that's probably going to be the easiest one to pick up on. Alternatively, you might have cases where you can have some large data files, maybe from some meta-analysis or a VPC, and they're stored somewhere else. They're not already being brought into Phoenix, and since you're going to process them in R, it doesn't really necessitate bringing it into Phoenix first just to then process in R. So you can create shortcuts in Phoenix, and I'll show you that, which are basically pointers to external files. And you can update that shortcut at any point. And what that means is at the beginning of your R script, you would tell it that there's a Phoenix shortcut, and then it would look for that file called residuals in this example. So those are two ways that Phoenix scripts are different. sorry, R scripts are different when you're using with Phoenix, just with these short header lines that we add. The third option would be using a dataset that's not in Phoenix, so that's like option 2, but in this case we've hard coded the location into the R script. So that might be what you do day to day with R generally, and obviously that's very transparent to a normal R user, that you're just reading that data file directly from wherever it's been stored on your network. But if you want to have a more flexible way, I suggest options 1 or 2. And then the fourth one is similar really to the option 1 in that there's a data set in Phoenix, but you don't put an attached statement. You don't need to put an attached statement in there. And what that relies on is that your R code, your R script, is expecting a column, a file and column names as they are already in the Phoenix worksheet. I can demonstrate all 4 of these in the demonstration in a few minutes. Okay, so that means that there isn't a chance to change it with the mapping panel. So that's the difference between options 1 and 4. Okay, then once that routine has run in R, that code's run in R, what we want to know is what can we bring back and reuse for further analysis or reporting within Phoenix. And essentially, anything that you write explicitly back to the R working directory will be automatically picked up and read into Phoenix. So these are examples of the sort of statements you might see. So here's something I've written a plot back to a JPEG file, and I can pick that up. But it could be PDFs, it could be PNGs, whatever. And the same idea goes for any data sets I might bring producing within the R script. I can have some sort of table statement written back to produce that worksheet. And then I'll also see that in my output, just like that screenshot we saw a few minutes ago. And again, any of the formats you might generate within R or you want to use within Phoenix, so XLS, CSV, dat.txt files, those could all be generated. And of course, plain text content. So typically that would be the R log file, but you might have some other output you produce you want to reuse elsewhere or just report on. It basically means that your R analysis is incorporated into your Phoenix workflow. It can be refreshed, it could be templated. All of those benefits of the Phoenix working environment are available to you who might not know a lot about R, but you want to use some clever code that someone else has written or you found on CRAN. So that's kind of the background. I want to just drop into Phoenix now and show some of what I've spoken about. Unless there's any questions yet, Anna?
No questions yet, Simon.
Okay. So I'm going to show a couple of projects. First one is a classic example of analyzing phenobarbital. In this case, I've analyzed it with Phoenix models. And there's some sub workflow where I did some development. And I've just moved my final model here to the root workflow so we can see it easily. And we can see that in here, there's the source data that's been analyzed, right? So there it is, source data Phoenix. And it's got these results. And within there is a residuals worksheet that I'm going to want to use and make some nice plots from. And obviously we get plots already from Phoenix here, but I want to show some other things. So I've got some example code. Now, most of this code is very similar. It's just differences in how it's being used in Phoenix at the beginning. So the first one is in the same order as I demonstrated in the slides earlier. This has got an attached statement. So it's going to create an expectation of a workbook called residuals, could be called anything, and an expectation of these columns. So I can simply say, I want to use that code. So I've brought that in from somewhere else, or I can copy and paste it in, but I've imported that code file, and I can simply say send to, go down to this external software. You can see there's these other third-party tools we can use. ggQuick's actually an R Shiny application we've added into Phoenix recently, but I'm going to use the R shell. And I'll just drop that into the root workflow. And you can see it's got this name R shell, and it's got this expectation of a workbook called residuals. So I can say I'm going to use that for my final model. I drop it in, find residuals. Again, it could be any worksheet. Everything that's got the same name is auto mapped. Anything that's missing, I can just click on. And then I don't need to change any of the code. That's all there for me. If I was going to edit it further, I could click use internal text object and make some further edits. I can create a subfolder for each run, which is probably a little bit neater. And that's it. I'm just going to execute. I'll show some other features in a moment, but let's just execute that first. So it's running off. It's showing the log that's been generated in R at runtime, and that's it's complete. The run's happened. I've got my plots generated, and they're just being sized to whatever size I need here. So I've got some nice, useful plots hopefully being generated in here. I've got the R workspaces being brought back because of this checkbox here. I've got a worksheet I asked for, and that was one of these last remarks in the script. Let me just scroll to the bottom here. So yeah, I just asked it to write out this worksheet here, and then I've had that pulled back into Phoenix to reuse elsewhere. I could send that off to anything else in Phoenix. Okay, do a plot or whatever. Okay. And you can see that's there and it can be used. Okay. So going back to this R shell, let's look at a couple of things. If I wanted to debug this, I could start the development environment. And I've got that set up to use RStudio, but you could use other tools. There's the native R GUI. We can see the file has been set out here, these batch commands, and the Phoenix script. And then I could take that script, click run, like I would do normally in RStudio. And it's going to go off and run that through and produce my plot. I've done something silly. I'll have a look at that later, but I'll have a look at that in a moment. So that normally will have brought my plot up. Not quite sure why. We know it works because we just saw it with that exact same script running. So something peculiar happened there. I'll move on. I'll have a look at that later if we have time. So, but yeah, that idea of starting the development environment is that you can bring it up, look at your code, and if you needed to debug it interactively in R, you can use that development environment. Okay. Then I want to show second way of working with R. So here it's the very similar script to before. So it's got these plots being generated. And the difference is these first two lines. So rather than having an attached statement, it's saying I want to use a shortcut. Okay. So I will go ahead and send that out to the R shell again. Put that back in the root workflow. And here, there's the code. And my file is looking for a shortcut. There's no mapping as such. And I can just take a shortcut I've already made, drop that in. I can check what that looks like by clicking View External Viewer. So you can see this is just my local drive in the folder I made for the webinar. And that'll pop that open. And again, you can see it's just the residuals data set again. And then I can go ahead and execute. It'll chug away there. Okay, and we get everything working correctly. So that's for the shortcuts. And since we've got some time, if you haven't created a shortcut in Phoenix before, I'll just show you that. It's under File, and rather than doing the normal import to actually bring the whole worksheet in, you go to Custom Import and then File Shortcut. And then you can browse off to find any location, or any file rather, click Open, and then it just creates a link to that file rather than actually importing the file. Okay, and that's what we used here. Everything we executed, we're bringing back, but sometimes if you're doing large runs, you've got lots of interim data sets being produced, you might want to actually set up some filters, and then you can say, okay, there's only certain things I want to bring back, and you can use wildcards within those, whether you want to bring in like units, rows, things like that. So, or nothing too large, things like that. So just a way of reducing everything coming back if you don't need it all back. There's some intermediate data sets you don't need, for instance. That's that. Just have another quick look at this development environment, because that normally is working absolutely fine for me. So we'll just see what it's thinking about now. Okay, so that one is not brought in the data set, so I'd have to point to it explicitly. Okay, I'm not going to do that because I know that one's not going to work. We'll go to the third example with the hard-coded link. So here we don't have a Phoenix specific header column where you saw those remarks, like here. See, it's got says this, so hash in R is a remark. So it's Phoenix that's reading that, not R, and it's that Phoenix shortcut. Here, it's a hard-coded link to the data set. So this data set's never been brought into Phoenix at all. And I can just send that straight to the R shell. Again, I'll just put that in my root workflow. And I don't really need to change anything at all here because there's no mapping to be done. There's no pointing to new data sets. It's all called in the actual file. So I'll just click execute. And we're all back again. Okay. And then the last example I wanted to show was slightly different. So it's not using the residuals output. It's going to use instead some data which you might use to make a forest plot for a drug label. So this worksheet here has got some parameters, some different sort of concomitant medications which were used. So it's like a drug interaction study and different treatment labels. And it's got results that we want to put in this plot. So I'm going to take this, and notice it doesn't have a shortcut or anything like that, but it doesn't have explicit code linking to an external file either. So it's not any of the first three options. There's this fourth option, so I send that to a R shell, put it back in the root workflow. There's the script. And this time what I use instead is the select sources, and I pick up the data file that's expected by the R script. You see this drug L. Okay, and then when I execute, it passes that all through, pushes it out to R yet again. And here we've got a different plot, show you've got the example. And what is great about this is what we've done here by linking to R is we've got all of the benefits of easily refreshing, seeing stuff's out of date. So if I go to this source data and say, oh, well, this value lower wasn't 0.9, but it was 0.1. Let's hope not, but it could happen. I can just change the source data. I can just re-execute that plot. And you can see this 0.1 has been extended. It was here back here, 0.9 before. That Cmax is now 0.1. So it's giving you all those benefits of being able to use some quite clever code, whether it's for plots or other activities in R that people have already written. There's some really great packages out there, and you're just using them in Phoenix by adding some way to pull that data in to Phoenix. From Phoenix out to R. And there's 4 main ways to do that. And we sort of bring the data back. We can reuse that data. So there's one other example I wanted to show from R, and that really comes from a common request of people who want to do some sample size calculations. So I'm going to move to a second project, and this is a bioequivalence example, and it's got this code here which uses something called power toss. So it's 2 one-sided t-tests. That's where this name comes from. Again, this has come from the CRAN network. It's published software. It's nothing to do with Certara. It has some dependencies for other packages. So those need to be installed once. And if you have installed them already, you don't need to run the code. Hence, I've got it commented out here. And it says run once, but we've just made it easy for people to reuse that. We're using the attach statement, and it's going to be picking up the final variances worksheet from a bioequivalence. I'm going to show that in a moment. The code's going to run along here, and this terminology here is really what you're trying to pick up and use. So we've got the theta 1, hopefully everyone can see it's not too small, and theta 2, let's say I'm looking at the 0.8 to 125 range. The theta 0, theoretically, you'd have that as being 1, because you'd expect them to be bioequivalent. But if you've already performed your bioequivalence, you would actually use the value that you get from your bioequivalence. Let me show you that. And where's that gone? Sorry. Yeah, so it's from these ratios. So we're looking at about 1.1 across these 3 different parameters of Cmax and AUC last infinity. So that's why I've got a value of 1.1 in there. And then the last bit of code was picking up from the final variance parameters. We've got the intra-subject CV. So we're going to be picking that up. Again, depending on what you've got, you might have a 10% or so on. In this case, data set is about 16% for these, and for the AUC, it's a little bit smaller, about 0.11, so about 11%. Okay, so we've got that information from the Phoenix's bioequivalence object, and we can send that again to our shell, put that in the root workflow. You can see the output we're going to be looking for is what sample size is going to be calculated for AUC and for Cmax. So just checking it off, we've got the 95% confidence, target power is 80% for both of those, log scale is true, and then I was just showing you these other values that have been read in. So that one is hard-coded to 1.1. Here it's actually going to be read in from the data set. Okay, and we'll pick that up in a moment by mapping that in there. So I can take that over, take the final variance parameters, names are all expected, so it auto matches. Don't need to think about that too deeply. Click execute. Again, it's going to take that worksheet, that script, push out to R, bring it back, and then I can just look through the log file, and we've got here the sample size for Cmax. We scroll down here, it says that we need a minimum power of 80, so it will round up to whole subject numbers. So it gets to 22, and that gives a power of about 0.82. And if I scroll up a bit, you'll see the same for AUC, and there at that confidence interval, we've got a sample size of 6, giving a power of 0.84. So you'd know, okay, I need to run with at least 22 subjects, probably give myself a couple for spare. I'll use recruit 24 subjects. Okay, so that takes us to about 25 minutes. I think I've covered everything I intended in the demo. I can always jump back later, I guess. So I'm going to drop back into the last couple of slides and take us to a conclusion. So the aim of this is not to be teaching you new R scripts. It's showing you how can you use R that's already been published, either on CRAN or within your own organization. If you want to use those, you can simply link them in, add the simple bit of header that I've indicated for things like attach statements. You can edit those further in either Phoenix's own text editor or by launching the interactive development environment of, say, RStudio. And everything you've done is recorded and then wrapped up in your Phoenix project for easy transport and cooperation with your colleagues. And then if you need to know more about that, you've obviously got the online help, which has got some example projects. I can show you that. It's in here. Just scroll down and there's the R shell. So I'm in the online help there. And you can see it's got a worked example, talks about how to set some things up and what you might need to do. Obviously, Certara University as well. We've got some recorded webinars covering things like the GG Quick EDA I mentioned before, but also this in more detail. There's a course on that. You can discuss this with other users on Certara's general user forum, which says the link. And of course, if you're still stuck, there's always our support site. So that really takes me to questions, Anna.
Yes, we have some great questions. Okay, so we have a few minutes here. The first question, when you were showing the R environment, you were pulling RStudio, and the question is, can we use TinR?
Yes, you can. It needs a couple of different statements to use correctly. That's one of the things about TinR, but those necessities are detailed in the help file. So there you go. Proper development environment for TinR requires this work and file directory to be set in the arguments field. So that was in that edit preferences I showed you before. RStudio's got just less requirements. So TinR's just got a few more bits of information that are required.
Okay.
But yeah, absolutely.
Great. There's some other questions, and maybe we want to show it live related to, is there any package in R that Phoenix requires to run this analysis? And maybe it would be, I know you showed the slide, but to show live where you actually set R in the preferences.
Sure. Yeah.
And then discuss that the packages are really not really required except whatever your script is calling.
Yeah. So I probably went too fast. Let's do that again. So I've got to edit, and then preferences. And then this is where you set most things in Phoenix. And we can take any of these third-party tools, in this case R, and say, okay, this is where my executable is. So if I click browse, I would just go off and find program files, R, there it is, I think it's bin, and then RXE, okay? And I've pointed to that. And again, I won't redo it, but you can see I've set up the development environment and so on. And if I wanted to always generate unique subfolder rather than checking it run by run, I could change that default there and just say, okay. Is that what you wanted, Anna?
Yes, I think so. And just the need that, Phoenix is a wrapper around
Yeah,
R, so it really doesn't really need any specific package. It's a little bit different than when we're going to be discussing RS and LME in the next.
absolutely. So yeah, this if I ran, somebody gave me some new code and it called for something. So here's an example, ggplot. So that's not a package that's in base R. So you just get an error message in your log file, which is come from R, saying I can't find the package ggplot. So you'd go probably using the development environment. You go to select those sources. Sorry, not select sources. Start your development environment, and then depending what you use as your environment, certainly in R, it's pretty simple. You can just go to Tools and Install Packages, and you'd say, okay, the script has told me by erroring out in the log file that I need ggplot, so I'll look for that, and you'd just go and grab that and pull down whatever it was, and it'd go ahead and install it. But that's an R thing, limitation, or necessity rather than Phoenix thing. In itself, Phoenix is just a wrapper, as Anna said. The only thing that is Phoenix specific is how we connect data at the beginning and how we bring it back. And that's what I was saying about these remark statements and how we bring that data in. So in this script, where we create an attach statement. Yeah. So you can see here the script says attach residuals, and it's got this remark winln in, blah, blah, blah. And then it starts with this, with the R script proper is everything after here. If you look at how that looks in RStudio, you'll see that it's actually had a read statement added in, which is been written by Phoenix to bring in that worksheet that we mapped in from a temporary space, execute in R, and then write it back at the end of it. Okay.
Okay,
Anything
I don't
else,
think
Anna?
we have, there's several more questions, but we do not have time to address them live. However, we will create a document with the answers, and they will be attached to the recording within Certara University.
That's great. Okay, so thanks everyone for their attention. Hope that was useful. And I should mention before I forget that my colleague Keith will have a presentation in a month's time, which will be the part 2 of the RSNLME presentation and cover a little bit more about how that can support pharmacometrics workflows. So thanks very much, and we'll put a copy of the slides up with the recording as well, so you can get to these links and so forth. So thanks very much for your attention, and I guess we end the session now. Thanks, Anna.
Yes, thank you, everybody.